It's a great pleasure to welcome Peter Gärdenfors to the Danish IAS. And Peter is foremost expert in cognitive science, philosophy, and host of related disciplines. He has published more than 300 articles and books on the topic, and is a professor at Lund University, leading the Lux group. It sounds like a luxury problem there for you. And so we are very happy that you will share your thoughts with us today. So thank you so much for joining.
Thank you for the introduction. Maybe I should say a few words about myself before I start. As Torbjörn said, I'm a cognitive scientist. My background is in mathematics, computer science, and philosophy. I also studied a bit of linguistics, as you will hear at the end of my talk here. And this will really be a cognitive science talk, and I'll explain why I do it. My research interests I should say something about this. This is a bit too weak, but it looks like a labyrinth or two halves of a brain. But if you see, you can see two letters, LUCS, meaning Lund University Cognitive Science, and that's the group I've initiated. But we also have a very big interdisciplinary research group at Lund called, this is CCL, and that's short for Cognition, Communication and Learning. So we are 5 different disciplines involved in that, and it's a big thing with PhD students and so on, running for 10 years. We are in the 8th year now, so it's almost finished. So these are my two home places at Lund University. Then I travel a lot, and I spend time at different institutes for advanced studies, and I very often meet Massimo Vaglien, who is my collaborator on different things. I mean, he has a position here as well, so I thought I'd talk about something what we've done together. So this is a theory event that we have developed together. But a little bit more about myself. I mean, I have, as Torbjörn said, I have had many interests in my life. I had a previous life where I did belief revision, logic, and decision theory. I have more or less left that. I'm still working a bit in decision theory, but more from an evolutionary point of view, because in my current interests are, well, one is concepts, concept formation, semantics for natural language, and we'll get into the semantics part here. And the other part is the evolution of cognition and communication. And these may seem as very different areas, but they are actually connected. And this theory of events I will talk about is something that bridges between these two areas. So that's all I want to say about myself at the moment. Then we get into the topic. Why should you be interested in a theory of events? I mean, why are events interesting? I mean, why should we care about events? And from a cognitive science point of view, it's quite central, because this is an interdisciplinary problem. It's mainly been studied by psychologists, and I'll tell you something about what psychologists have done with events. But it also comes into literary studies, linguistic studies, because when you're studying narratives are structured according to events. You need to know what an event is in order to analyze a narrative. So these are 2 application areas. But as I will try to convince you today, events should be of interest in many more areas. And I'll try to give you examples here. So why it's interesting for me is that I think that events, I mean, for me, events are cognitive entities. I mean, you can be a realist and think there are events in the world, and maybe they are, but I'm only interested in how we represent, as humans, represent events in our heads, or wherever we do it. And I think it's as fundamental as how we represent space, how we represent objects, how we represent actions. I mean, these are fundamental notions for mental representations. And I put events among these. I mean, really basic for human thinking. And I think there are good evolutionary reasons for it as well, but I'll get into that. And then, in particular, I think that reasoning about events and reasoning about causes are very tightly connected. And you will see this. So I mean, causal reasoning is very central to lots of sciences. And I think there is a kind of parallel between causal reasoning and events. So these are my motivations for looking at a theory of events. So let's start. Yeah, okay, this is another motivation. I forgot about that. I'll get at that at the end. I mean, the role in language, understanding language. Now, I have a wish list, and it's a long list. Events have parts. I mean, you can divide them into different components and different segments and so on. They relate to causal structure and counterfactual reasoning. They can be ordered in hierarchies. You can have big events that you can partition into sub-events and so on. A trip can be divided into sub-trips and so on. And they can be formed into sequences. They relate to episodic memory. I don't know how much I will talk about the episodic memory. Episodic memory is, as it says, a memory of episodes. And there is Talving's theory saying that there is procedural memory, knowing how to do things, how to ride a bike, for instance. There is semantic memory, knowing the meanings of words or meanings of how to sort things in the world. And then there is episodic memory, remembering events and the sequences of events. So almost by definition, events relate to episodic memory. They are temporal. We should know something about how children learn events. They should be connected to actions and connection to semantics of language, in particular verbs, because verbs describe the actions that form the core of events. This is a long wish list. I will talk about some of these points today, but not all of them. But this is what I think a full theory of events should contain. By the way, I don't mind if you interrupt me with clarifying questions. I mean, the big questions we'll save for later, but if you want to ask a clarifying question, that's perfectly okay. So, philosophers have worked on event theories, and I don't really want to talk about them, but most philosophers think of them as a kind of metaphysical analysis. What is there in the world? What would an event constitute in the general theory of metaphysics? Donald Davison is one of the people who started this kind of work. Jae-Woong Kim has continued. I don't want to get into it, but I'm not doing the metaphysical studies. I'm doing the cognitive studies. I mean, I'm not really, I shouldn't say I'm not interested, but I'm not building on this philosophical tradition. I'm doing the cognitive models. I mean, this is what I want to do, mentally represented. But I also say that it connects to language. And linguists have been interested in how can we find the expressions of events in language. And I'm just complaining. I mean, for those of you who have a little bit background in linguistics, this is one definition of the meaning of the verb break. So, X breaks Y means that X acts in a manner that causes Y to become broken. This is a typical formalism from formal semantics in linguistics. I don't like this. I like the cause part, but you see, break disappears here, and here is broken. It's written in capital letters with italics, so it's supposed that we know what broken means. But basically, this doesn't tell us very much about what break, the verb break, means, since we still have to know what broken means in order to understand it. So it's a fairly empty description of the meaning of break. So, okay, I don't want to complain too much about linguistics, but anyway, this is a typical formalism. And as you see, very much, both in philosophy and in linguistics, has been done in terms of symbolic representations. And I have, as a kind of mission, to avoid symbolic representations of knowledge. I want to do it in terms of geometry or vector spaces instead. So I want to do semantics in terms of geometry, and I've recently published a book on that topic, and this is to some extent part of what's in that book. So, what I want to do, okay, no, before I get into the theory, there is a tradition in psychology, and there is a book by Radvansky and Sachs with the title Event Cognition, and it's very recent. And that's a kind of, I shouldn't say Bible, but it's a summary of all the psychological research that's been made on event cognition. And it's very comprehensive, but it misses some essential elements, I think. They are focusing on well, let's say, they give their definition. So this is the definition taken from the book. An event is a segment of time at a given location that is conceived by an observer to have a beginning and an end. So this is also a cognitive notion, because it's dependent on the observer. But for me, this is a very thin definition. It doesn't say very much. I mean, it's a segment of time having a beginning of an end. It doesn't say really what is the structure of an event. I think we can say more about it, and that's why I'm standing here today. I mean, I want to say more about it. But that's the definition. And quite a lot, yeah, this is what I already said. It says nothing about the constituents of events, and that's what I want to do. And they also write, I mean, another part of the book is connections between event and episodic memory. Quite a lot of the research, psychological research about events, has been about how we segment events. We see a movie, we hear a story, and all kinds of experiments have been made to ask people, where does an event begin and where does it stop? And as a support for this definition, there is actually quite strong support that people are fairly consistent in drawing the same borders between events. So we can partition a story in events. Okay, sometimes we make longer segments, or sometimes we make shorter. But anyway, there is quite a large amount of overlap between where people do the segmentation of the events. So we have some kind of common perception of where events begin and end. And this is the basis for their book. It's mainly about event segmentation. And in my opinion, too little about event structure. So now we get into the theory. This is what Massimo Mai, I mean, this is a very simple theory, but still I think it has fairly strong implications. So this is the picture of the theory. There are two vectors. One is a force vector, one is a result vector. There is an object that's a patient. That's what an event is, something happening, and this is what it happens to. Patient can be an object or a human, or lots of things. And often, but not always, they're an agent doing something that starts the event. But as we'll see, it's not really necessary. So this is the theory. Now let's see the force vector, and I really want to emphasize that we think of it as, well, if I'm pushing the table, there is a force vector, there is a direction, and so on. But if I'm walking, or if I'm throwing a basketball and so on, it's a bit more complicated. It's a pattern of forces that is generating the action. So simple model, force vector. More complicated is a force pattern. Then and it comes from force space. I mean, generated by an action. I'll get back to the details of this. The result vector describes the changes of the property of the patient. So if I'm pushing the table, what's happening sometimes is that the table moves. That's a change. It changes location. If I'm heating a soup, the temperature of the soup is changing. That's an event. If I'm breaking an egg, the structure of an egg changes, and so on. So the result is to describe the properties. Sometimes it's a change in location. Sometimes it's a change in different properties. I'll talk much more about that. States are special cases of events, and that's when the result vector is zero. I mean, it's just nothing happens. But there might be forces and there might be counter forces. I mean, if this glass is standing on the table, that's a state. but there is a gravity force and there is a counter force from the table. So there is a balance between forces in this. So what makes it a state is that the result vector is, there is no change in properties. Okay, I already said this. Now, sometimes the agent and patient are identical when I'm doing things with myself. When I'm walking, I'm generating a force pattern on my body parts, and as a result, I move in space. Or if I'm jumping, similar things. I mean, we can have actions on ourselves. That's also events. The agent is not always necessary. If something is falling, if I, well, I can't push it because then I'm an agent. If this happens to fall down, I mean, there is gravity acting as a force, but there is no agent, no action done. But there is still some force that makes it fall. Or if a tree is growing, there are internal forces in the tree that makes it grow. There is no agent generating the force. Okay, in growing it might be a bit of a marginal case. But typically there is an agent. One thing to emphasize here is that time is not explicit in the model. We don't assume the time dimension. If you remember the definition from Laswansky and what's his name? Oh, I've forgotten the name. Shit. Sachs. Laswansky and Sachs. Sorry. They had a segment of time. I don't think this is necessary, or we don't think it's necessary to have it. Of course, we can derive time from the development of events and so on, but this is not primitive. Time is not such a primitive factor in the human cognition, according to our opinion. And people would fight a lot about this, but I leave it for the moment. But just to note that we don't use the time dimension. It's forces and results. So of course, there is a dynamics. Of course, there are changes. Yeah.
Clarifying question: if you say agent, do you think of a person, a human being?
No. It could be machines. It could be animals. It could be. I mean, anything that can exert a force can be an agent.
Wind.
Wind could be an agent sometimes. Yes. Wind. Yeah. I mean, this is a bit strange because we make wind into an agent. This is a change in our mental construction. So wind is a thing we can discuss.
If you have continuous forces and continuous results, how do you isolate an event?
Good question. In general, the force vector starts and ends. So the beginning is the initiation of the force vector, and the end is when the result. Well, there are. Sometimes it's a process, and then it's continued. But if it's an accomplishment, then there is an end of the result vector as well. So, but beginning is very often initiating a force vector. I mean, if I'm continuously walking, it's an event without a really sharp. Well, I need to start walking, and sometimes I will end walking, but that's maybe a very extended event.
Just as a question, I mean, from this naive point of view, I would think that the zero vector could be defining beginning of end even in a continuous space.
No, I don't follow you. Once again.
Your zero vector could define the end.
Yeah, when it becomes to the state. Right. Yeah. The zero vector is a point in the property space. Yes, you're right. We can get back to the technical details because I'm getting into some examples here. So here is a typical, prototypical example of an event. I mean, this is the agent, this is the patient, there is a force vector, you're pulling this sledge up a hill, and there is a result vector. The force vector and result vector are not parallel because there are friction and counter forces and so on. So I didn't mention the counter forces, but they will come back here. So that's just a typical example of an event. And it could be an ongoing process here. And now we get into a very important part. The force vector is the cause. The result vector is the effect. I mean, this is more or less a simple picture of what causation is. So there is a strong connection between events and causal relations. Yeah, I've already said this. Philosophers have spent very much effort on trying to define causes. What is different of this theory is that cause and effect are different types of things. The cause is a force vector. The result is a change in properties. In general, people think that causes and effects have the same kind of ontology or the same kinds of things. But we don't. And I think that's quite important. Another thing, now we get back to evolution of human mind. We have a tendency to put in agents in event representation. And now I can get back to your wind. We make the wind an agent. That's I shouldn't say it's an animism as such, but Piaget has this very nice example of when a tree is moving in the wind. Children will think that the tree is an agent, that the tree itself is moving the branches and so on. And there are lots of examples of animistic thinking in all kinds of cultures. And I think your wind example is good because it shows we still have some form of, we want to put an agent, we put a name of it, the wind, as the agent of something. That we want to fill in this, even if there is no agent, physically speaking. The human mind has this tendency to fill in agents. So here is an example with small children from the 1940s by Michaud. He showed simple movies where A is moving towards B and then there's contact and then B starts moving. Or in the second case, A moves towards B but there is no contact and then B starts moving. And then you ask children or adults what's happening. And in this picture, it's felt that A causes B to move. But down here, there is no such feeling. First A moves and then B moves. No causal relation. And Michaud did all kinds of variations of these movies to find out when there was perception of cause. And he defined it in terms of transmission of forces. So, I mean, in this case, I mean, there is the momentum of A is transferred into the momentum of B. And here there is no transmission of forces, so it's no causation. That's an early analysis. I don't think this covers everything, but it was a very interesting beginning, and it gave rise to a lot of experiments on perception of causal relations here. So there should be contact. There should not be too long time delay. I mean, if this takes a couple of 100 milliseconds before B starts moving, then people becomes, subjects become less and less certain that there is a causation. So this is experiments concerning causal perception. There is a book by Povinelli with the title Folk Physics for Apes. And he made a number of experiments showing that apes have problems in understanding causation. Surprising problems. And this is a good example. This is a peanut. And this is a transparent glass tube. And the chimp is given a stick, and it can push the stick through the tube here, and if it pushes it in the right direction, the peanut will come out in this end. But if it puts it in this direction, it will fall down in this pocket, and it won't get a reward. So guess what the chimpanzees do? They're given 50 trials here. Yeah?
They attack it from the closest edge.
No.
Oh.
They do it randomly.
Ah.
They don't learn it. They don't learn it. I mean, after 50 trials, they still do it randomly. Very surprising. I mean, more or less randomly. There was one chimpanzee, female called Megan. She learned a trick. But she did exactly what you're saying. She learned to push it so that the stick passed the bulb before, not the closest end. She pushed it from this end. She got but in order to test that she understood what is happening, they turned the tube upside down So this bulb was upside down, and it didn't matter which way you put the stick, because you wouldn't get the reward anyway. But she still continued to push the stick first over the bulb and then to the peanut. So she didn't understand the gravitation point here. This was very surprising when it came out, and it's been criticized and discussed, but basically apes don't get the point here. I mean, it's very surprising. Here are other experiments from the book. You have rakes, and this is a reward. And if you take this one, the ape is given a choice between pulling this one or pulling this one. That's what is within reach for the ape. And I mean, any child that can pull anything will pick this one. Apes pick at random. Here, one is upside down, one is correct. If you pull this one, you don't get a reward. If you pull this one, you get a reward. Apes pull at random. Here is a hole in the board. This is just a black tape put on top of the board. If you push this one, you don't get a reward. If you push this one, you get a reward. Still random. And similarly with this one, this is floppy, and so you can't pull where this is stiff. So, yeah, this is very surprising. So there is something has happened to our causal understanding. And even small children, I mean, as soon as they can pull the thing, they will solve this problem without any, well, they sometimes may make mistakes, but so causal understanding is very different. Philosopher Woodward has made a classification of 3 kinds of causal learning. One is what he calls egocentric learning, and that is what the child does first month of its life. You notice if you flip around with your hands, you will hit something in the pram and it will move, or if I bite my toes, it will hurt, and so on. You learn about what happens when you move your body parts and the effects of moving your bodies. And this is the first type of causal learning, and the child does this automatically. And we can model that by simple conditioning, and if I do this, then this will happen, and so on. Then, second level is agent causal learning. And then you learn about causes from actions of others. You see somebody else opening fruit and you're eating what's inside it, and you learn yourself how to open this fruit. This is imitation, learning by imitation. You see how others do some actions and get the result. I mean, this is you see events of this. Doing something, bodily forces on an object, and something happens. And then you can map that onto your own body. And for those of you who are interested in mirror neurons, you can tell that story, but I don't want to get into that. I mean, this is where mirror neurons are supposed to come in. And then we get to the third level, and that's what Woodward calls observation causal learner, where natural signs and patterns are seen as causes. It's not only human bodies. I mean, this is not only they are seen as agents. And there are a couple of famous examples from the studies of monkeys here. This is the track of a python in the sap. And if you study vervet monkeys, python is one of their worst predators. So if a vervet sees a python, they panic. If they see a python track, they don't react. They can't reason from the presence of a track that there might be a python in the environment. If you put up a dead antelope in a tree, this was done by Cheney and Seifert, 2 monkey primate researchers. A dead antelope up in a tree is a very good sign that there's a leopard close by. And leopards are also predators of the vervet monkeys. They don't care about dead leopards, but if they, I'm sorry, they don't care about dead antelopes. Of course they care about leopards. And I mean, these are leopard tracks. If you show leopard tracks to a vervet monkey, they don't care. So,
but you can train them though.
You could train them, yes. That's another story. But I mean, this is not, and then it's human intervention to do it. But that's a kind of conditioning. I mean, conditioning sure. on. But I mean, this is.
But don't you think that's also an element of conditioning in our understanding of these things? I'm just throwing it out. Maybe.
I don't think so.
Okay.
But it's a good question. That's something we could discuss. Humans follow tracks. All cultures, I mean, you learn to understand that this is a track of an animal. You can learn that to categorize it as a leopard track. I mean, it's not easy. Leopard tracks and hyena tracks are quite similar and so on. And we've done that for a fairly long time. So something happened in the human evolution. I mean, dogs don't follow tracks. They follow odors. They can't read a track. They can follow an odor of somebody. And all animal following other animals is done by olfaction, not by visual track following. So what's happening here is that we reason from the effects to the causes. That's an effect of a python. We reason to the cause of this pattern. We go backwards in this kind of reasoning. We see the result. We imagine the effect, the agent behind this result here.
But isn't that the same with the scent that the dog follows? Is instead of visually following a track, it's
yeah, no. There are differences. Now I don't remember what are the differences between. Okay. I would say that the dog is conditioned. I mean, this I would explain with some form of conditioning. Yeah? There is no mental picture. And there are differences. Okay. If you have two crossing trains, the dog may be confused at the crossing points. The human will see where the two can separate the two trains. Scents are not that good at that kind of separation. If you have mixtures of scents, you can't make a separation. But we can keep track of an animal even if it's confused. So yeah. Okay. But this is so. Getting back to this classification, animals do these two levels of reasoning, but they don't do this one. So humans seem to be the only ones who can reason about from effects to causes when it's natural, the natural science here. Okay, now Massimo and I wrote a paper with Jürgen Jost that some of you know here, and we said that what's interesting in the event model is that the causality really concerns the mapping between the forces and the result. There is a mapping. When you have this force vector, that's an input to a causal function, and you have the result as an output of the function. You need to learn this mapping in order to understand the causal relations. And once you start thinking of it, this mapping can be seen as the source of a lot of what other people have talked about as naive physics. Well, we are not good physicists when we are born. I mean, but we have certain principles that we reason by. And with Jürgen's help, we identified 3 constraints on the mapping. And for a mathematician, this is fairly simple. One is that we think of the mapping as being continuous. If we increase the force, the effect will be increased. If I increase the force when I'm pushing here, then it will go further away or it will go faster or whatever. So small changes in the cause leads to small changes in the result. That's more or less the definition of a continuous function. It's monotonous. If I have a larger, okay, I'm sorry, my illustration was the monotonicity. Larger forces lead to larger results. And the third one is convexity. Intermediate results are caused by intermediate forces. If I'm throwing darts or shooting at something, and first time I shoot too high or hits too high, next time I hit too low, then I try to find something in between in my thing. We're interpolating in our adjustments when we are practicing and so on. We're using this kind of convexity principle. So this doesn't identify the mapping function, but it's still 3 fairly strong constraints on how we map from causes to effects. So given our model, we can get a lot of the naive physics out from the mathematical properties of, and these very fundamental mathematical properties of the mapping function here. Now, yeah, go ahead.
If you push your glass slightly, it will move towards the edge. At some point it will topple and you will not have a continuous result.
Thank you. I should have said that. Continuous is not not
So
perfect.
piecewise continuous.
Piecewise continuous. Thank you. Piecewise continuous. Now, I had break earlier, but we could also have push here. But let's take break. I can bend a stick. I can bend something. And if I bend it, it bends more. I mean, we have the continuity, we have the monotonicity. But there is a point when it's not continuous anymore. What happens then is that we perceive it as another event. The discontinuities are signs of that. They are conceptualized as a different event. So, of course, this function is it's piecewise continuous. But it's also a way of identifying events when there are discontinuities. And that break, that very discontinuity is called by a particular name. It's the breaking of the stick. So that it gets a special name. But thank you for the comment. Yes, that's very good. Okay, we talked about agent, patient, force vector, and result vector. That's the kind of minimal model. Linguists have analyzed what are, they call it thematic roads in events, and there are more things. Okay, officially we represent this model in terms of conceptual spaces, and an agent is an object, but it is an object that can exert a force, that can generate a force. That's how we identify agents. Patient could be any object. It's category space, physical space. All patients normally have locations in typical events. The patients have locations in space and have certain properties. We can think of abstract events as well, but I don't want to get into that. Sometimes there are recipients, and in particular in human interactions. I can give you a book. Then I'm the agent, the book is the patient, you're the recipient. And I will, if I have time, I will get back to that situation. Then you have three objects in the event. That could be instruments. I could push this with my finger, but I could also push this with something else. I could have an instrument. I can hit a nail with my hand, but it will hurt, so I hit it with a hammer. And that's instruments can be seen as transformations of the force vectors. A hammer will amplify my force. A stick will lengthen my action radius and so on. Yeah. So we have instruments of different kinds. And I also already mentioned the counter forces exerted by the patient there. So the mapping becomes complicated sometimes because we don't always know what are the counter forces. And even more complicated is when we take the intentions of the agent into account. But let's see if I have time to get into that. I probably don't. Okay. Anyway, we can talk about hierarchies of events. What is this? Give me a name. What is it? It's an event, but what is it? Come on. Give me a word.
Clearance.
Olympics.
Yeah, okay.
The Olympics.
No, it's okay. No, okay. It's a bodily action. Well, very abstract. A sport event. Yeah, very expert. Individual sport event. It's not a team. It's a track and field event. Now, yeah, it's a high jump. It's a Fosbury flop if you know something about high jumps. I was expecting you to say a jump or a high jump, because that's what's called the basic level in prototype theory. We have a particular level of categorizing events. So events also go by this kind of prototype levels here. And we talk about event categories. I mean, this is an example of a high jump, but it's also an individual or a particular event. So we can make the same distinction between categories and individuals here. We can segment events, and we have all kinds of complex events like trip, marriages, parties, tennis matches, movies, whatever, political campaigns. Lots of events can be segmented into parts. And as I said, this is what's been studied by psychologists quite a lot. And I already said that they agree to a large extent on event boundaries. And this is a speculation, because when the psychologists have studied these borders, they haven't really tried to analyze why we make these borders. They just find that we are very consistent in making them. And our speculation is that the borders are where there are big changes in force patterns. When forces are initiated or when they're stopped. So this would be a way of going back to the data and look for changes in force patterns. We haven't done it. I don't think anybody has done it. But this is a speculation that we would see event starts and ends where there are highest changes in force patterns. If you have a sequence or a segmented event, you can ask how do the pieces hang together. And yeah, okay, we say that force patterns determine the segmentation here. Sequences of events then. How do you aggregate sequences of events? Well, if you have a trip, it's the same patient. I mean, I went here from Lund to Odense in the morning, and I can segment it. First I took my bike to the station in Lund, then I took the train from Lund to Copenhagen, then I spent a few minutes in Copenhagen railway station, and then I took the train to Odense, and then I took a taxi out here. This is my trip here. I segmented into this. What is continuous here is that it's me. I'm the patient of it, and now you can follow my trajectory, and that's what makes it a big event. And in general, you can do that. I mean, you can sequence event by continuity of the patient and agent over the stories. And this is what we normally do when we tell stories. I mean, we follow a couple of characters through. But you can also action and result chaining tails to tips. If I do something, if I move it, then there's a new position, and then I can move it further and so on. You can take the end of the result vector and take that as a beginning of a new result vector and chain them in that sense. That's another way of connecting events. And this is, yeah, what Olga said. And of course, we can analyze narratives, how people tell stories, to see how they think about how events have changed. Timo.
I think it's super fascinating. I was still thinking about the initial question, how you isolate events, and that relates to this slide. Like if you would push the table accidentally during a cocktail party, it would be no event at all. The same thing happens during the cocktail party. Something falls off in rooms, your colleagues' wife's dress. Then suddenly it's an event. So, so I think it's about the individual mind and the story in the individual mind, and also about the collective mind, like in a marriage, that you collectively attribute. So there must be somehow the observer or the collective observer, and then you can kind of isolate it.
Thank you. It's a good point. I mean, if I accidentally kick the glass and it falls over, I would still count it as an event, but it would not take part of, not really take part in my story of the party or whatever. But if as you say, I mean, I destroy the dress of somebody, it will be rememberable, remarkable. So when we tell stories, we mainly talk about what is unexpected, what is not following a general pattern. The expected thing people are supposed to fill in by habit, so to speak, or by expectations here. So there is a difference between identifying events and selecting events for what is interesting to tell in a story. And I think that's the point you are making here.
But then there's an infinite number of events that are never labeled.
Yes.
Like, you know, you just move around and you move the little dust on the ground. Everybody of us does it billions of times per day. And
there is an infinite amount of events, and we don't perceive them, we don't think about them. So we have no cognitive representation of them. But if we focus and we put our attention on movement of the dust, we would see it's an event. But it's just that we don't make any representation of them.
But isn't this a question of efficiency? We can't. We have to focus somewhere.
We can't. Yeah. We have a focus of attention, and lots of things, lots of events we don't attend to. So I didn't really bring in attention here, but that's how we select things. To when we tell a story, I mean, we attend to certain events of the party or of the football game or whatever. Okay.
Excuse me.
Yeah, go ahead.
About stories, do we need to have already something in mind, some theme that we're trying to make, so that we pick the events that are going to end up to that theme that we're going to enforce, or that is not part of it here?
Let me try to explain this by giving you some example of experiments that have been done. I mean, this is typical experiments. And this is from a paper by 3 people here. And they watched short movies. These were either kindergarten children, 4-year-olds, or adults. So they saw movies like this. I mean, these were cartoons. A boy skating into this net. I mean, that's a typical movie. You can imagine. They saw 20, 30 movies. I forgot it. And they followed the eye tracking of the adults or the 4-year-olds. And they asked them questions afterwards. What happened? What did the boy do? Where did he end up? And so on. And both the 4-year-olds and the adults had good memory of the events. There was no. They encode the events in the same way. I mean, in my terminology, they did look both at what happened and the result. I mean, the action and the result. Now, there were these 3 differences when they started talking about it. And there are basically 3 ways. Now, we're getting into language here. They're not really narratives, but how you describe events. So there are 3 basic ways. One is to say, the boy skated into the net, then you have both the force vector, the action, and the result. Or you can just say the manner, this is what linguists call the manner verb, or the result. And it turns out that if you ask the English speakers, the adults, 70% of the adults had both manner and part. They said the boy skated into the net. While manner only, that is saying that if the boy went into the net, was done by most of the preschoolers. Path only was very seldom. It was very rare. Yes, he went into the net, but still. So there is a big difference. The adults had both the manner and the result, the force and the result, but children only focused on the result. I'm sorry, on the manner, how it was. He was skating. They didn't do this. Now, interestingly, they did it, Papa Fago is of Greek origin, and she did it with Greek children as well. And there is a difference between Greek and English, and that is, linguists say that Greek is verb-framed. Greek and Spanish, Romance languages, in contrast to English and other Germanic languages. English and Germanic languages have a lot of manner verbs. And we describe paths with prepositions, basically, into and so on. While the verb frames don't have so many verbs, they say it entered, the boy entered the net instead of skated into the net. And then you get path only as a result. So the type of language is focusing more on path here, while in English it's more focused on manner. And that's a cultural difference in a sense. But they represent both components, because when they ask them memory questions, you get that they have perceived both cases, but then they select different parts when they're telling the story. Partly dependent on age, partly dependent on language. So that's a fairly typical example. Another series is done by Golden Meadow and her colleagues on, she's studying sign languages, or signing in general. And she did this in let's see now, Turkish, Chinese, English, and Spanish. And these languages are interesting because in Chinese, English, and Spanish are SVO languages, subject, verb, object. While Turkish is an SOV language, subject, object, verb. And when they gesture, they all gesture subject, object, verb. While when they speak, the Turkish, of course, talk subject, object, verb, while the others, I mean, Chinese is a little bit in between, but both English and Spanish is only subject, verb, object. So when they speak, they follow the pattern. But the interesting thing is when they sign, they were supposed to sign, or that I kicked you or something, and then I do you, and then kick. So they first do the agent patient, and then they do the action in signing. And that turns out to be fairly universal. And one idea, this is from Golden Meadow, the verb is relational. I mean, it's a relation between subject and object here. So relata must be introduced first. before you can tell the. So the question is, well, she thinks of this as the evidence for cognitive primacy of SOV structures in thinking. It shows up very naturally when people start signing. While many languages, I mean, most in the European languages are SVO languages.
Also, because I'm not familiar with the details of sign language. Is there different endings? So do you have a difference between kick, kicking, kick, kicked, so the different tenses of it?
No, you can.
Because that would explain it, right?
Yeah,
If I can only say kick, I can't say I kick you if it's past tense. I would have to say you kick, and then you would have to do the grammatical translations in your mind, right? That it has happened.
I'm not an expert of sign language, but you can mark tense. You can mark that something happened in past tense.
Okay.
You do that by hand is backwards, for instance. Yeah. So, but you can do it. I mean, sign languages are as rich as spoken languages. But don't ask me about the details, because this is, And they did something. This is home signing children. These are children that have not been taught sign language. These are the ones, the kind of signs that develop between a parent and a deaf child. And they sign in a similar way, which is the SOV structure again. And her conclusion is that the central elements of a motion event, I mean, that you have to, you're representing the agent, the patient, and the action. That representation is done without language. They have some kind of event representation. And in these home signs, the homemade sign systems, they still have the representation for these three parts, and they do it in that order, the SOV order in signing. So that's another study of Golden Meadows. Let's see now. Yeah, and one more thing is what they, now these are signing children, American deaf and Chinese deaf children. And now we get back to these different components I was talking about. This is the endpoint of the result vector, if it's a movement. This is the agent. This is the location. I didn't talk about that. The recipient. And the start of the result vector, if it's a movement origin. And what they call figure is what I call patient here. And what you see here is that all of these signed events include the patient. That's the central part. And then you have a bit of agent, you have the result vector is very much signed and so on. But everything, this is very strong part of these are nominal elements. I mean, the representing things. And these are the verb elements, path, motion, and manner. I mean, that's, motion and manner is what I call the result vector. I'm sorry, manner is the force vector. Motion and path are different result styles here. I should stop soon. Agents are often deleted. I mean, you see, lots of these sign messages don't include the agent, but they almost always include the patient. So you forget about the agent when you talk. I should stop soon. Let me do a little bit of semantics here. All languages have something that we call sentences, some kind of unit. Why is a sentence a unit? We have words and we have sentences. I mean, we can always partition something. I mean, if you look at an animal sound, you don't find these units. I mean, you can find some segment, but it's not as a human language. And you don't find sentences. So why are sentences so universal? Next question, what is the meaning of a sentence? Why do we have them as cognitive units, or linguistic units, I should say. And if you ask a logician, they would say that the meaning of a sentence, following Frege, is a proposition, and a proposition is a mapping from possible words to truth values. I mean, it's a truth value, basically. Not very interesting answer, in my opinion, if I may say so. So what is the meaning of a sentence? Well, my answer is the sentences refer to events. A sentence is a unit to describe an event. That's why they are units, because they describe events. Or states, if you like, but sometimes the sentence is about state. So, here is a semantic thesis. A semantic expression is a part of an event. I mean, we can't talk about everything that's happening, but we are focusing on something involving at least one of the vectors, a force or a result vector, and at least one entity, and the entity is typically the patient, but we can have cases where there is only focus on agent. So a sentence focuses on some parts of an event. You don't describe everything involved in an event. And constructions become different depending on what you focus on. So if I say Victoria hits Oscar versus Oscar was hit by Victoria, in the event model, Victoria is the agent, Oscar is the patient. But if your focus is on Victoria, you put her in the first place, then she becomes the subject of the sentence. I mean, she's the agent, but now she becomes the subject. Here, if you focus on what's happening is to Oscar, he becomes the subject. So in Indo-European languages, or yeah, I've forgotten what the classification is, subject is not doesn't always mean agent. It means the one that is focused on, the one that we are attending to. There are some languages, ergative languages, where subject is always agent and patient, object is always patient, but that's a different story. So there is no simple relation between agent, patient, and subject, object, not in Indo-European languages at least. So agent, patient is the cognitive thing, subject, object is a marker of the focus of attention in a sentence. But anyway, this is my explanation of why we have sentences. They refer to events. I will go very quickly over this part. Actions, I've talked a little bit about that, so yeah. I want to just get into verb meanings as well. The meaning of a verb is a complex region of vectors that depends only on a single domain. So, in a single domain, I mean in this case, we can have verbs that refers to the force vector of an event, like push. Or we can have verbs that refer to changes in spatial domain, like move. Or we can have changes in properties, like heat or break or whatever. In this case, it's changes in the temperature domain. And my thesis is that any verb is just about one domain. It's either about the force domain, or about the space domain, or about some kind of property domain. That's a fairly strong thesis, but so there are no verbs that mean walk and burn. That's an odd meaning, but that involves different domains. There are no verbs that means crawl or run, because as action patterns they are quite distant, and couldn't form a convex set of force patterns. I'm sorry, I'm doing this very quickly. Okay, let's do the metaphors. This is about a boy who had spilled milk on the table, and he was sucking it up with his mouth, and he said he was vacuuming the milk with his mouth. It's a nice metaphor, but it's invented on the spot, because this sucking is like the sucking of a vacuum cleaner. So yeah, or you can say slicing a tennis ball. Normally you're slicing a bread, you're moving your hand in this kind of direction, and slicing a tennis ball is doing like, well, that kind of movement. Now, linguists divide verbs into manner and result verbs. So let me just give you examples here. So, push as a manner verb. That means force applied to an object, and this boy is pushing the door. And typically, the push leads to a change in the position of an object. But the mapping from the force vector to the result vector is not automatic. I mean, here are counter forces. The door is going out the other way, so nothing happens. And you can explain this. You expect that when you push something, that will open. You would phrase this event as saying that the boy pushed the door, but it didn't open. The but marks that there's a break of an expectation here. And then you have result verbs. They describe changes in object. And here is a man painting a house. And the result is that the house becomes covered in paint, of course. And I've picked this picture so you can't see whether he's doing it with a brush or with a roller or maybe with a spray can. The manner here is not important. The painting means that he's covering it with paint. How he does it is not marked by painting. So it's a result verb. And don't determine the forces and so on. So what I'm doing here, and I'll finish now, is to show you how this event model can be used in analyzing certain aspects of the semantics of language. I've talked about sentences, and I talk about how you analyze the meaning of verbs. And the basic division is that there are verbs for the force vector and there are verbs for the result vector. I'll stop here. And I hope you're giving you some use of
Thank you so much, Peter. And we have quite a few questions along the way. There are two more. Let's take time out for these questions. And before that, I have a proposition. And that is, we all go up afterwards and talk a bit more, or at least enjoy some food. There's some bites there, a few drinks, and we can discuss a bit more about Jens. But the two questions. So you had one.
So, thank you, Peter. Just quick question, whoops, coming from where I come from, the ecological perspective. So, because I'm a bit, hesitant about how you interchange between the linguistic data and cognitive data, as if there's a shared layer of representation there, which of course builds on the view that cognition must be representational and language must be some kind of uttering these representational patterns. So I was just wondering, I mean, if you go to the ecological psychology, you would find a lot of theories about events that don't share these representational ideas.
Yeah.
And I was just wondering, how would you make that fit into your story, or would you just reject that because you say that cognition by definition must be representational?
I wouldn't reject it, but as I said at the beginning, I think that Radwanski's and Sachs' theory is lacking to describe, they don't describe the structure of an event. They're interested in the beginning and the end. I mean, that was what's part of the definition. And I want to use the event model as a basis for a semantics of certain parts of language. I mean, I can't talk about nouns and adjectives and so on here, but verbs at least. So this model, including the components, I mean, of the two-vector model and some extra components, I see as the semantic representation that we then use to talk about. I mean, that's what language refers to, these things. So I identified an event as a unit, and the unit comes out as a sentence in language. So I don't know if this answers your question, but still, the important part is that other event theories have, in general, I mean there might be exceptions, forgotten about the internal structure of events.
Yeah. Well, but you don't really. You talk about the perception of events and the representation of perceptions of events, but not really the events. Unless
this is a cognitive theory. I talk about the mental representation of the event.
But you could have cognitive theories that talk about the interaction between the animal and the environment as a similarly cognitive theory that doesn't take that representational level as explanation.
Yeah.
That's my point.
No, okay, that's fine. Yeah. I mean, of course, there are other aspects. If you want to go be a realist and talk about, I mean, then it's a different theory of events. But I'm talking about the mental representation of events. Yes.
Yeah. Thanks.
Lars, got a question?
Yeah. Thank you for a very inspiring lecture. I just wanted to hear your take on a completely different branch of knowledge, where event is actually a key concept, namely history. So, as far as I can see, the development has been that the event is still a sort of the nuts and bolts of history and the way you teach history and so on. But of course, on the philosophical level, even historians have become less sure about the realism of events. But these are, of course, very complex narrative structures also to represent historical events and so on. I'm just curious to I just wanted to chip in that event is actually a very important but also quite unanalyzed piece in historical philosophy.
Yes, and I know very little about the methodology of history, but I've still understood that when I was a kid I was taught about kings and wars. I mean, these were the big events. But then historians have changed and look much more at the low-level structure of societies and economic changes and whatnot. They've changed the focus what are the interesting events. I mean, different scales, different focuses of description.
But they haven't gotten rid of events actually.
No, they
So,
don't. But the question is what are, I mean, as somebody said, there are infinite number of events happening. The questions are which are the interesting ones. And that has changed over time, which events historians think are interesting. The ones we want to talk about. So writing history is very basically selecting a small number of events from the infinite mass that has passed.
So, Peter, here's a t-shirt.
Thank you.
They're famous, and I'm not sure it will serve you on the way home, but
okay.
I hope it will serve you.
Later.
And thank you so much for
Thank
joining
you.
us.
Thank you for the questions.
And I hope all of you will join us up there, and there'll be, of course,